Graph 11. So as the number of masses in a system increases, A, how does the behavior of the system change if you displace just a single mass? That picture on the left there shows that, and then C, how does the number of modes change? Picture on the right shows the answer to that question. As the number of masses in the system increase, how does the behavior of the system change if you displace a normal mode? Each normal mode swings in a certain pattern, and that pattern stays the same no matter how many masses are added to the system. However, when the number of masses in the system increases, the amplitude of each normal mode can be amplified or compressed due to the swings of the other normal modes. However, it does not change the actual swing motion itself. Then this was another question we addressed. It is, if just a single mass is moved, how much does the computer figure out which modes to turn on and off by how much? The goal of this was to make the height of mode 5 as high as possible. So the picture below just shows like what it would be if it was normal and 0.
Okay, so when the amplitude of odd modes are changed, we saw that the amplitude that we changed, that corresponding mass was heightened, and then mass 5 always increased in amplitude. And for even modes, it had the opposite effect. So if you heightened mass 2 and mass 4, mass 5 went down.
So in order to try and counteract the effect changing the amplitude of the even modes have, we tried to look at the phases, and we found that if you change the phase of the even modes 2 and 4 to pi instead of 0, that increases the height of 5, of mode 5, as you can tell on the 2 pictures below. And then this picture shows when we put it all together. So what we did was we increased the amplitude to its max of both mode 1, 2, 3, 4, and 5, and then we changed the phase of the even modes 2 and 4 to pi instead of 0. And as you can tell by the picture, this combination of the changes to the system makes the height of mode 5 as high as possible. Actually, the mass is completely outside of the picture because it's so high up. And then the last thing we did was to show an example of how it would look if we tried to increase the height of mode 5 in a system with more modes. So this system has 9 modes, and as you can see, all modes except mode 5 are aligned perfectly at equilibrium. And what we needed to do here to get that to happen was we needed to change the phase of 3, 4, 7, and 8 to pi to counteract the decrease it has when you try and change the amplitude. And then we changed the amplitude of all the odd modes, which gives a system that looks like the picture below.